Okay, now I want to move. Okay, now take a look at this. We normally start with a skilled population. What do we mean by skilled population? A population, that is maybe most of the data fall to a particular side, whether to the right or to the left. That's what we call a skewed population. So a skewed population is not normal. This is not normal, okay? But you know what? Because working with a skewed population normally requires an extra statistical or mathematical effort. And we're looking for a way to simplify situation. Working with normality assumption, if everything go okay, always make our work very, very easy. And that's why we want convergence to normal, of the distribution to normal. Take a look at what I'm going to. Oh my God. Let's say we got a random variable y, that is skewed, whether skewed to the right or skewed to the left, provided we choose a sufficiently large sample, the distribution of the sample means we follow normal. You can see that. And maybe we started with the income of individual may be skewed, okay? But when we actually do a sampling distribution where we do a repeated trial, okay, we allow simulation and we get a lot of sample means. Then, provided the sample size is large, of course, the distribution is going to be normal. And when the distribution of the sample mean is normal, or the distribution of sample proportion is normal, that will give us an opportunity to be able to use, we can find the probability associated with a sample mean, with a sample proportion using normal statistical table, because assumptions of normality, let me tell you this, central limit theorem facilitate normality under certain condition. Normality facilitates standardization and z-score. Does that make sense? Okay, now I want to move right now. Okay, now I what are the step-by-step implementation of central limit theorem in a real-life business problem? Let's say we have a company now, and we actually maybe we're producing, and what we produce varies, maybe in number, in number, okay, and we actually want to know uh what is the average. We want to get a true average. We want to figure out the true average. Number one is define the problem. What do I want to do? Oh, I want to know the amount, the average amount of the quantity that we produce in this company. Oh, or I want to know the average household income in a particular country, or or I want to know the true average vaccine effect. Stuff like that. I want to know different kind of stuff. We're going to start by defining the problem. Then the next thing is to figure out the sample size. Okay, but you know that you know how to figure out the sample size. By central limit theorem, we expect the sample size to be at least 30 if you're for working with the mean. Then we decide on the sample size. Then we're going to collect the data. When we collect the data, we calculate the sample mean. Then we repeat sampling. Why are we repeating sampling? We want to have several means. Does that make sense? Because you can't do sampling distribution without having several means. Several means is like you go into the population, you choose sample size, at so many occasions. In each occasion, you figure out the mean. Now, if you visit the population 1,000 times, you're actually going to have 1,000 means. Why are you doing that? You're actually doing that because having more than one mean will give you an opportunity to be able to know whether the distribution is normal or not. Does that make sense? Okay, so what you're going to do next, right? You calculate the means of the means. But let me tell you this. What do we call the means of the means? Oh my God. The means of the means is actually, give me 1 second, is what I call expected value of y bar. That is the mean of the means. Y by itself is a mean. Expectation is a mean. The mean of the means. If I go 1,000 means, then I'm going to get the mean of that. Does that make sense? Oh, what is the next? Then I'm also going to do the standard deviation of the mean. So which means I will first need to start with the variance of the mean. Then when I get the variance of the mean, the standard deviation of the mean is actually going to be the square root of the variance of the mean. Okay, the moment I go there, oh my God, I'm set, I'm set, I'm set, I'm set. Okay, the moment I get all of that, the next thing is to apply the CAT, apply the central limit theorem, and don't forget. So now that is the procedure. Any question?